Okay. Hi everyone. My name is Monsi. I'll be leading today's Crimebusters and Forensics workshop. I hope everyone can see my screen. So I guess if you can't, let me know. Otherwise, I guess we'll just get started. So obviously this is the Crimebusters and Forensics workshop. So first I'll be going through the rule sheet for both divisions, and then I'll go through some difficult topics that you might encounter during the tests. And then we'll do some questions that you'll see on the tests. And then I'll give you guys some tips and other free resources you can use to help study. So the rule sheet for Crimebusters. So each person on the team gets one 8.5 by 11-inch cheat sheet, and that's per person. So you and your partner can have information on separate cheat sheets and bring those. So this is like standard printer paper size. And so I highly recommend putting different information on each cheat sheet and avoiding any overlap if possible, because that way you guys can divide and conquer essentially. So for my cheat sheet, I use this website called Canva. It's a free designing software, and it really helped like organize everything and condense a bunch of information onto one paper. So for Crimebusters, you also get one non-programmable calculator. So that means no like TI-84 or scientific graphing calculators. So think like four-function or non-graphing calculators. This goes for both events, but make sure to wear the proper clothing. So this includes like appropriate goggles, an apron or lab coat, and long sleeves and pants. So some event supervisors are super strict about this, and I've seen people who weren't allowed to take the tests because they were wearing short sleeves or their pants were above their ankles, something like that. So be sure to bring extra clothing if you don't think yours will suffice. Um, so Crimebusters and Forensics have different materials that you're allowed to bring. So be sure to check the chemistry lab equipment list at the end of the rules document for everything you can bring. But on the slide, there are some examples of things that you definitely will need during the test. And for Crimebusters, the qualitative analysis, so the analysis of the powders, solids, liquids, mixtures, those have the most points on the test. And that's also in the rule sheet. It says about 50% of the points will be allocated to that. And so the rule sheet for Division C or forensics. So the cheat sheet rules are the same as Division B, but for Division C, you are guaranteed to be tested on powders, so Part 3B, and the polymers, which are detailed in Part 3C. So most of the time, especially if the test is in person, you will be required to use either paper chromatography or TLC, but it's usually paper chromatography. However, it often depends on the competition you're going to. So say it's a virtual one, then obviously they won't be able to help like have you guys do the hands-on lab equipment stuff. So one big difference between divisions B and C is the depth that you need to know for each category. So obviously, as you move higher up, you're expected to know more things. So Division C covers more powders, polymers, and you need to know them in greater detail than Division B. Once again, check the chemistry lab equipment list that's at the end of the rule sheet, and make sure to bring the things that you're allowed to have. So you can't, if you bring something that you're not allowed to have, event supervisors might not let you bring that into the test, and you'll have to keep that somewhere else outside. And for forensics, the analysis of the crime at the end has the most points. So make sure to write something, if anything, down there. Are there any questions so far about the rules? Obviously, during the workshop, feel free to stop me if you have any questions. Okay, I guess there are no questions. Or, let's see. Um, you're not able to hear me. Can anyone else hear me? Just, I guess I put it in the chat. Okay. Um, maybe if you could try leaving the meeting. Okay, that's good. People can't hear me. So you can try leaving the meeting and coming back. Otherwise, this is always going to be recorded. So you can always come back to this later if you need to. Okay. If there aren't any questions, then I guess we'll just move on. Okay. So some topics you might encounter during exams. So the first one is chromatography. So often you'll be given a paper chromatography to complete, and most of the time it's for matching an ink sample to a suspect. So you're given an ink sample that was found at the crime scene, and you're given a bunch of pens that maybe suspects used, and you're asked to find out which one matches the crime scene the best. So chromatography relies on two concepts, capillary action and polarity. So capillary action is the movement of water against the force of gravity. So think of like water moving up a straw. And when you do chromatography, you'll notice that some compounds move up the paper more than others. And this is due to polarity. So this is because some compounds are more attracted to the solvent, which is usually water, than others. So that causes them to move up the paper more than others. So typically water is used as a solvent, but on the rule sheet, it says, especially for Crimebusters, that you may be asked to do chromatography with other liquids. So obviously practice with those, see how it changes, but most of the time, water is the usual one that you'll find. So one key thing you'll be tested on in a chromatography section is measuring the retention factor. So that's the ratio between how far the compound moves and how far the solvent moved. So to calculate the retention factor, um, first measure how far the compound, or as it's labeled in the image in the bottom right corner, the substance. So you need to calculate how far that moved. So first you start at the baseline, which is the pencil line you draw at the bottom of the paper, and you measure from there up until the center of the compound. The second thing you want to measure is how far the solvent traveled up the paper, otherwise known as the solvent front. So sometimes the ink may break up into its different color components. And from that, you may be asked to find the different RF values of each component. So as you'll see in the picture on the slide, some of them broke up into different components, some of them didn't. But usually for this one, you'll just be asked to calculate the retention factor of the whole component overall. So the solvent is often called the mobile phase because it's the part that moves, while the paper is called the stationary phase because it doesn't move, it just stays sitting in the solvent. So I recommend starting the chromatography at the very beginning of the test because it takes a while for the chromatography to develop. And if you wait until later, there's a high chance you'll forget that to do it until it's too late in the test and you don't have enough time to analyze it. So what I did when I did forensics is you want to designate one partner to do the paper chromatography as the very first thing. So basically, as soon as you open the test and you see that there's a paper chromatography you need to do, have one partner just immediately start it before doing anything else. So that way you guys are set up for the rest of the test and you don't have to worry about that until the end when you need to calculate retention factor and match it to a suspect. So one big thing about chromatography is that you got to practice it. So obviously watching tutorial videos and maybe just knowing how it works could help you in a test, but you don't want to walk in blind and just hope for the best that you know how to do it. So at least once before your first test, try and practice with it. Try and like put a bunch of different like pen or marker dots on a piece of paper and just try doing a paper chromatography with water and see if you can come up with a good method to do it fast with the lab equipment that you're allowed to use. So sometimes during a test, the paper chromatography might not work as well as you want it to. And if that's the case, just do what you can with it. So even if you try to do something, you'll be given points in most cases. And obviously try your best to calculate retention factor. If it doesn't work out as well as you want, then you can't do anything about that once you've used it up. So chromatography, it depends on your sample that you're given, but often I'd say to like a safe extent, it takes around maybe 10 minutes. Obviously, it might take less than that for some different substances. You know, it's time to take the paper out when if you look at it um, after a few minutes and you see nothing's changed, then you know it's time to take it out. I obviously don't recommend leaving it submerged in the solvent for the entirety of the test. I'd say as a good measure, halfway throughout the test, take it out and see if it's and if you can analyze it. Okay. So the second topic you guys would be tested on are animal, plant, and synthetic fibers. So while Crimebusters just has to identify out of these three fibers, forensics has to differentiate between the multiple types of each fiber. So Crimebusters just has to determine if the given fiber is animal, plant, or synthetic, but forensics has to determine if it's animal, and if it's an animal fiber, is it wool or silk? Or if it's synthetic, is it polyester, nylon, or spandex? Things like that. So for this workshop, I'll keep it between the three different types of fibers, as there are very specific distinctions between the various types of each fiber. And to figure out those distinctions, it's better to do it through practice and come up with your own methods rather than just relying off of what somebody else observed, because what you may observe could be different than what someone else observes. So it's like if you think one thing smells one way, you might think it smells another way, and then it could lead to confusion during a test. Okay. So to identify fibers, you can, oops. Um, okay, yeah. So to identify fibers, you can either use a microscope or a burn test. Um, I think my slide got deleted, so I will be checking that really quickly, but just give me a second. Oh, I'm lagging and glitching. Okay. Does anyone else have that issue? No? That's odd. Okay. Um, maybe you could again try leaving and joining again. Otherwise, you could just watch the recording once it comes again. Okay. So yeah, I'm sorry about that. I don't know how to fix that. Okay, here's the slide. Sorry about that, guys. I don't know where it went, but yeah. Okay. So getting back to it. To identify fibers, you can either use a microscope or a burn test. So when I did forensics, I preferred a burn test because I practiced it a lot. So I was pretty confident in my abilities to identify what fiber I'm looking at based on just the results of the burn test. So for those of you who may not know what a burn test is, basically during the test, you're given a candle. So think of like those IKEA circular candles. And sometimes you're either given a match or the event supervisor has a lighter, which you can ask them to light the candle for you. And along with that, you're given a couple pieces of sample fabric that were found at the crime scene. So what you want to do is take maybe like tweezers and hold a piece of fabric close to the flame. And you want to analyze how that fabric reacts when it's in contact with heat and the flame. So by analyzing the process and the aftermath of the fiber sample burning, you should be able to identify what the fabric is. So things you can look out for are what the flame looks like, what it smells like, and maybe like the color of the smoke it gives off. So for example, animal fibers give off really dense gray smoke. And those are some key things you can look out for when doing a burn test. So animal fibers typically smell the worst of all of them. They once you if you practice burning wool, you'll obviously be able to recognize it again once you burn it again during a test. But those so wool and silk would smell the worst out of all three. They kind of smell like charred hair, and meat, which makes sense because they are animal fibers. Plant fibers typically smell like burning paper, which also makes sense given their chemical composition. Synthetic fibers typically have a sweet, and you can tell it's a very chemically smell. So animal fibers are made of this protein called keratin, which is often found in places like your hair and nails as well. So a common characteristic of their burn tests is that they shrivel up in the heat and they stop burning when you take them away from the flame. Okay. So plant fibers, those typically have a constant rate of burning and they have like a yellow-orange flame. And then finally, synthetic fibers, they melt in the heat and form a small plastic bead when they're cooled. So that bead is usually a cream or gray color. So be familiar with looking at microscope images of fibers. So sometimes the test may not give you all of the fibers in physical form, and they might give you microscopic images of them. So you want to be comfortable looking at both types of it. So also, if you're not comfortable with burn tests, then if you're given a microscope, you could also do this as well with your fibers. So one key thing to look out with between all of these fibers, and this kind of goes in depth for forensics, is the wool kind of looks like a sort of branch with all these random like ridges coming out of them. Um, Cotton, if you can see it, has all these twists in it. And linen kind of looks like bamboo, which is a great way to think about it because once you see that, you'll know immediately it's linen. Synthetic fibers kind of almost all look the same. They are very uniform and clear cylinders. So you have to basically know really well what the synthetic fibers, each of them look like. And that obviously requires practice and time. And silk, the last one, that curls up a lot. And yeah, you can see it in the image. Are there any questions so far about chromatography, fibers, anything like that? Okay, I'll move on. So the final topic I'll be covering are polymers, or the plastics. So plastics were literally on every single forensics test I've ever taken. So it's really important to know them well. So I'll go more in depth about some concepts about plastics that show up a lot, but can be difficult to grasp. So even though plastics don't, you're not allowed to do the burn tests for plastics because some of them release toxic gases. The burn test results are usually given to you. Um, so those results of the burn tests might not be enough for you to distinguish between two different types of plastics. So you also need to be familiar with the density tests. So density tests are when you're given multiple different liquids and you have different samples of the plastic. And your goal is to use the fact whether the plastic sinks or floats in that liquid to determine what the plastic is. So plastics can be divided into two different categories. The first ones are thermoplastics. So these can still be molded back into their original shape after heating. So the forces holding them together are weak. And because they can be molded around after heating, these ones are highly favorable for recycling. On the other hand, thermosets are the opposite. So they can't go back to their original shape after being heated. So these are made of these things called cross-linked polymer chains, which have very strong intermolecular forces, and that gives them a very rigid structure. So once the plastic is heated, the chains are irreversibly bonded together, which makes it unable to go back to its original shape. So in the pictures, you can kind of see the difference between a branched and cross-linked polymer. So the branched polymer shows just obviously different branches coming off of one chain, but cross-linked shows you have multiple chains connected together. Okay, so you may also need to know how these polymers are put together or synthesized. So I've been saying polymers and plastics pretty interchangeably, and they can be considered the same thing. So polymers are just these long connected chains of a group of a single repeated component known as a monomer. So if you look in the bottom left image, a monomer is just like a small molecule, and then a polymer is just that small molecule repeated multiple times in the same pattern. So that's kind of just a distinction between them. So to make these polymers, you'll have to go through one of two basic types of polymerizations, addition or condensation. So addition, also known as chain growth, is when you add one monomer to another. So then you have polymers that are added together one step at a time. So this one kind of grows linearly. So think of like your y equals x line, where you add one polymer, then you add another, and you add another, and the chain just keeps growing. The other type of polymerization is known as condensation, otherwise known as step growth. So this doubles the polymer chain with each step. So it's a form of exponential growth. So this process uses water or sometimes alcohol molecules to help join the monomers together. So sometimes water or ammonia are byproducts of condensation polymerization. So the top right image shows what condensation polymerization looks like. So if you see the highlighted molecules, so you have the OH and the H. So as you guys may know, water is H2O. So these two components would add together to make H2O, and that would come outside of the molecule, and then you can join the two, the acid and the diol together, and produce water as a byproduct. And then the bottom right image is addition, polymerization. So this one, it basically shows you have this ethene monomer, and all you have to do is add just another monomer to it to get a polyethylene polymer. Okay. So these are so we'll be going through some common questions. So you guys might want to get out like a piece of paper and a pencil to write on because you will have to do some calculations. Okay. So for this question, you guys are given a bunch of different density test results. So you have plastics A through D, and you have if they float or sink in those given compounds. And I gave you guys the density of each plastic and each solution, and they're all in the same units, so you don't need to worry about that. Obviously, this might not be given to you on the test itself, so be sure to have that on your cheat sheet somewhere because I can guarantee you will have to use it. So I'll give you guys about 5 minutes to see if you can do this. And if you need more than 5 minutes, just let me know. Okay, so have fun with that question first. And if you have any questions, feel free to ask. Okay, so it doesn't give the density of 25% NaCl. So yeah, that is a good point. So I want you guys to see if you can figure out what you would do in this sort of situation. What is something you would do to work around that? If you were given um, saturated NaCl, that is given on the um, density table. It's shortened to sat NaCl. Yeah. But for 25%, I want to see if you guys can figure out what you can do if you aren't given the density of a specific solution, but you're given the density of a solution of two solutions that are close to that. So kind of see if you can work around that. I'll give you guys another minute. If you're done early, just hang tight and I'll reveal the answer soon. Okay, is there anyone who needs more time to answer this question? If you do, just say so in the chat. Okay, and I guess we can move on. So here are the answers. So A is polypropylene or PP. B is polystyrene, PS. C is PMMA. And D is PC, polycarbonate. So for this, since you didn't have the exact density of 25% NaCl, then you can use the two closest solutions to estimate the density of that. So often this could happen on a test where you might not have every single liquid that they expect. And to work around that and just come up with an answer, you can use the nearest two solutions and their density to estimate what it could be. So in this case, since you don't have the density of 25% NaCl, but you do have the density of saturated and 10%. So you know that 25% NaCl would be more dense than 10%, but less than saturated. So you can assume its value would be between 1.071 and 1.202, right? And because of that, and if you worked through the problem and you noticed that um, C was PMMA, and you notice that plastic D has it sinks in everything except one compared to plastic C, which sinks in everything except two. You can notice that it has to be more dense than PMMA, which means 25% NaCl has to be more dense than 1.16 grams per cubic centimeter, which means that you can estimate it to be greater than 1.16. And so at that point, you can assume that it's greater than 1.16, but less than PC, which is 1.2. And when you search it up, the density of 25% NaCl is really between 1.15 and 1.2. So that logic kind of works out. So if you're ever given that sort of situation on a test, you should always analyze what you have to work with and how you can use that to your greatest advantage. And so the second part of it, drawing the monomer structure of peat, that one, if you couldn't do that from memory, that's totally okay. Obviously, you have a cheat sheet given to you, so you can use that to your greatest advantage. But if you knew it, then that's good. Otherwise, it can always be on your cheat sheet, even your partner's cheat sheet, doesn't matter. Are there any questions about the answers to this one? I guess we can move on. Okay, so here's the second one. So I know we didn't really cover blood typing in this workshop, but blood typing or hairs, but they are two very, very common topics you'll find on tests. So just see if you can solve these questions. Otherwise, I'll obviously go through and explain the answers to them. For blood typing, it may be useful on your cheat sheet to have a table that shows all the different blood types and their reactions. Okay, so I'll give you guys maybe, let's say, another 5 minutes to solve this. If you have any questions, feel free to ask. Font size for your cheat sheet, I would recommend, I feel like 4 or 4.5 might be small, but for me personally, I would size up. So I would say 4.5. Um, Obviously, make sure to print both of them out and see which one you can read better. So since I did my cheat sheet on Canva, I just checked the font size that I used and I used 10. Blood type reactions are for Division C. I'm not entirely sure if they are for Division B. I can double check, but they might be on Crimebusters too. They aren't? Okay. Well, that's totally fine if you don't know it. Obviously, you can try the question if you want, but if you are going to keep doing like Crimebusters or forensics, then you will need to know it. I personally only did forensics, so that's one I'm more well versed in. I'll give you guys another minute to answer these questions. Totally fine if you don't know them. They're just good questions to get exposed to before any tests. So the main difference between forensics and Crimebusters is the amount of materials you're supposed to know. So Crimebusters focuses a lot on the like powders, solids, liquids, mixture analysis that's in the rule sheet. But forensics focuses on that along with a bunch of other stuff. So you're kind of given equal weightage to the powders and all the polymers in forensics, while Crimebusters focuses mainly on that. And a big part of forensics is also the analysis at the end of the crime scene test, like part of the test. So for that, they kind of just want forensics, they want to see more of your overall thinking capabilities. So whether you can put all the different pieces of evidence you're given together and determine a single suspect. Otherwise, a lot of the content they cover is the same. It's just forensics. They expect you to know more about what goes on behind all of these processes. Um, okay, are blood type reactions just how the antigens react to a different blood type and what antibodies they produce? So yeah, blood type reactions are basically just how the antigens on the red blood cells react to the different blood types. So it causes the body to produce these things called antibodies against any of these foreign antigens it may encounter. So when you see a reaction, that's called a coagulation. It's kind of called like, it's this clumping sort of thing. Okay, so I guess we can move on to the answers for this. So the answer for the blood type one is O positive. So anti-A is antigen or antigen A, anti-B is antigen B, and anti-D is to test for the Rh factor, which is if it's plus or minus. So because it reacts with the anti-D antigen, that means it is a plus in the blood type. So that means it has the Rh factor. So I briefly mentioned this earlier, but hair is also made of keratin, and melanin is what gives hair its color. So if you notice, as you age, your hair turns gray and white, and that's because the hair produces less melanin. So that's usually a fact they kind of might ask you to know. And the medullary index, that's related to hair and the ratio between the medulla width and the cortex width. So these are two components inside the hair. And basically, animals have thicker medullas than humans, which gives them a greater medulla index. And so different animals have different medullary indices. And so that's how you can kind of determine between the two. I have not been asked to calculate a medullary index before, but you may be asked to given whatever type of test you may be taking. So that is, again, just a ratio. Okay, are there any questions about this one? Okay, we can move on to the last question. So this one is finally chromatography. So you're given the crime scene chromatography and the results of the chromatography from 5 different suspects. And so they want you to first calculate the RF values to 2 decimal places for the red, purple, and brown dots. So they give you the lengths that each of the dots are at. And so you don't have to measure anything. You can just look at it on the crime scene. So they just want you to calculate the RF values from the crime scene chromatography. They're asking what does RF stand for? And they're asking for which pigment was most polar and least polar based on the crime scene chromatogram. And if you can, try and answer which suspect is implicated based on this chromatography results. So I'll give you guys another 5 minutes for this. And yeah, feel free to ask any questions. Okay, I'll give you guys another 2 more minutes to answer these questions. If you're done early, just hang tight. And if you need more time, just let me know. Okay, if you need more time, just let me know. Otherwise, I'll be going through the answers now. Okay, so for the um, RF values, so the way you would calculate it here is, so first you want to find the distance the compound traveled. So you know that starting at your baseline, you're at 0.8 centimeters, and the red dot is at 1.5 centimeters. So to find the distance it traveled from the baseline to the red dot, that's 1.5 minus 0.8, which is 0.7 centimeters. To find the next part of the ratio, which is the distance the solvent traveled, that's the distance between the baseline and at with the image they gave us, it's the top of the paper. So that would end up being 4.8 minus 0.8 centimeters. And so that would give you 4 centimeters. And to calculate the ratio, you would do the distance the compound traveled divided by the distance the solvent traveled. So you would have 0.7 divided by 4, which comes out to 0.175. And since I asked to round to 2 decimal places, you should round up and you get 0.18. So that's kind of how you would solve this problem, is you want to make sure that you're finding the distance between them, not just how the numbers they gave you and how far it looks like it traveled. Because in this question, the 1.5 is actually starting from the very bottom of the paper, not the baseline. And you want to make sure you start at the baseline and work your way up. And so you would apply that same thing that I just said for the red one to the purple and the brown dots as well. Right? And then RF stands for retention factor. Some people call it retardation factor. Retention factor is more commonly used, and that one is equally as acceptable. And so in this case, the most polar compound is brown because it traveled up the paper further. That means that so as you guys may know, polar and polar work well together, and non-polar and non-polar work well together. So it's kind of like attract. So in this case, the more polar compound travels up the paper more because it's attracted to the water and they both travel up the paper. So this case, the brown one moved up the furthest, which means that's the most polar. Since the red one moved the least, it's the least polar. So that's kind of how you would solve this question. And then, as a couple of you guys said in the chat, Caden is the suspect who would be implicated. And to implicate a suspect from chromatography, you basically just match up whichever suspect's chromatography matches with the crime scene chromatography. Sometimes it might not be as exactly matched up as this image shows, but you would just use your best judgment skills, and you can also look at retention factor numbers that you get. And if the values seem to match each other more, then that would be the suspect to implicate. Are there any questions about this? Okay, and I guess we can move on. So tips from someone who's done this before. So my first tip is to practice with your cheat sheet. So once you make it and you have it all set in the way you want it to, take a couple practice tests with your cheat sheet physically with you. So that way you can dig through it as you need to. And by the time you go and take a test, you know where different things are. So the worst possible thing to do during a test is to waste time digging through your cheat sheet, hoping that you find a piece of information. But if you practice with your cheat sheet in a practice test, you know where things are located and you know where to find them. So it makes it a much faster process. So my second tip is to split up the workload of things you need to learn in the rules sheet. So since I did forensics, I recommend the powder and polymer split. For Crimebusters, I recommend that you both learn the qualitative analysis part since it's the biggest part of it. And from there, you can split up the knowledge for the rest of the topics, making sure it's an even split. So for the powder polymer split in forensics, that basically means that one person learns all of the powders, the flame tests, the chemical reactions, all of that. The other person learns the polymers, so the hairs, plastics, and fibers. So I took the polymers, so the hairs, plastics, and fibers. That's why I know that stuff better. So we split up that stuff because those were guaranteed to be on tests no matter what, and they were two of the biggest like groups of content that we needed to know. So it would be very difficult for one person to learn all of it by themselves. So for the rest of the information, such as fingerprints, DNA, blood, we split up that information, just going one by one. So if I took fingerprints, then my partner took DNA, I took blood, they took something like entomology. So we split up all those pieces of information and put different things on our cheat sheets. Okay, so my tips for identifying powders and liquids for Crimebusters, I would say this is going to sound so repetitive of me, but just practice. So I would recommend laying all of it out there and reacting a bunch of different ones together and taking note of that and seeing, okay, what's the pH of, say, this liquid? What's the pH of this mixture? And then see if you can make like a diagram, a flowchart, a table, something that would help you reference back that information again. So that way, when you're given the mystery like mixture during a test, you can refer back to your notes and realize, okay, so if this mixture has these properties, this is what could be in it. And that way, you know what you're doing in that situation. So it really just takes a lot of practice and making sure that you really know the different powders, liquids, um, solids, all of that stuff like the back of your hand. Otherwise, it might be a little more difficult. Okay, so yeah, during a test, I definitely recommend like splitting up the sections and dividing and conquering. So I've heard of some teams doing a lab and test split where one person would do all of the physical lab components while another person would do all of the test questions. And I don't really recommend that because sometimes you have a lot of test questions and not a lot of physical hands-on lab components to complete or vice versa. And in those situations, you would leave a lot of the test on one person, which is really difficult to try and get done in the given 50 minutes that you have. So during the test, timing is key. Sometimes you have so much evidence to get through that you can't possibly get through all of it in the given 50 minutes. So in that case, maximize your points. Look through the test, flip through each of the sections and see what has the most points. So as I covered earlier, forensics, the analysis has the most points. But in Crimebusters, the qualitative analysis has the most points. So since for forensics, the majority of the points are in the analysis. Always write something down there first. So my analyses always started by writing down each of the suspects' names and leaving a bit of space so I can write down more information there later. And after reading through like the background of the crime, I would write down what each suspect's motive could be. So let's say someone had something stolen and one of the suspects was someone who had a fight with them. Their motive could be that they didn't like that person because of the fight, and so they wanted to get back at them by stealing something of theirs. It's a really vague situation, but that is something you would most likely get points for because you have a motive written down for that suspect. So at the halfway point during the test, try and write down which evidence matches up with which suspect, because that is always another key point where you can get points. Bullet points are totally fine. Don't even worry about complete sentences. As long as your handwriting is legible, you will get points for something. And then when you have around 10 minutes left in the test, have one person devote the rest of the time to writing up the analysis and implicating a suspect. That is a huge part of the analysis points is if you implicate the suspect and you implicate them correctly. So to implicate a suspect correctly, that's basically just who has the most amount of evidence matching up to them and who has a compelling motive. Some suspects might not have a motive, but some might have ones that are more likely than others. Okay, so yeah, it helps to keep pretty organized notes, and as always, practice, practice, and practice. Okay, so some resources, these are all linked, and you guys will have access to these after the presentation, but they have Forensic Science Simplified has a bunch of different links you can go through to practice learning about blood, fingerprints, all of that. So split up the tests. That I would suggest splitting up the test. That is the one way you could get through the most of it. So yeah, your split depends on what you guys want to do. I recommend doing what I said earlier, powder polymer split. That seemed to work really well for my partner. So these are some resources you guys can use if you need access to chemicals or lab equipment. So Ward Science, it's also linked on the official Science Olympiad website, and those typically contain forensics and crime buster kits, which have all the solutions, powders, polymers, etc., everything you need to complete the test. So those, uh, although they cost some money, they they would work for a long run, for the long run, and they have enough resources that you can use them multiple times. Otherwise, I suggest talking to your school's chemistry teacher or biology teacher to see if they have any equipment you can use, any chemicals or powders they have for you guys to use. Um, yeah. So obviously, also talk to your coach about things you can buy or things you can practice with. Other than that, thanks for attending this session. I hope it was helpful to you guys. If you have any questions for me, please feel free to ask. Um, if you want to see my cheat sheet, I can show you guys. I used Canva, so that was really helpful. Otherwise, you guys are free to go. This is going to be recorded. So yeah, the cheat sheet, sure. I can show you guys. Okay, so this is what my cheat sheet looked like. It's really small and really compact, but it definitely helped so much. Like, I kid you not, this was one of the greatest things I had. So these empty boxes are where I wrote um, I wrote if it was addition or condensation polymerization, and I drew the chemical structure of the monomer. So these are all my plastics. These are some extra facts about the plastics, the hairs, of all the different animals, parts of the hair, um, like phases of hair growth, things like that. And then I have all my fibers. So these are all microscope images that I compiled, and that way I could look at them throughout the test and be like, okay, this seems to match this one. I think it's this one. It has a bunch of facts about the hairs. These are the flame test results. So I personally, oh, these are all fibers, sorry. So I did the burn test, and then I wrote down my results and observations, and based on that is what I used during my tests. So I didn't really just copy from a website or from a video. I actually did it in person, and I would highly recommend doing that. I was also given blood and fingerprints. So I have pictures of fingerprints, some information about them. I have a blood typing diagram right here. I think it was super helpful. Just quickly reference it, and that way I know exactly what I'm doing and what blood type I have. Um, so yeah, that's how I did it. These are just all text boxes, pictures, things that I put together. You can zoom in and out in Canva, and it's really helpful. So I would recommend using that.